Alright, math homework. Here we go. Starting with some ACT practice. Number 1, what is the value of x when 2x plus 3 equals 3x minus 4? Just saying, you could technically use the answers to go through this, plug them in one at a time. Put negative 7 in for x there, put it in for there, and see if they come out to be equal things. I'm just going to solve this the algebraic way. But I'm just saying you could use the answers if you were ever asked to solve an equation that you didn't feel good about. Let's see. Looking at x's on both sides, I can minus one of them from the other. That would give me 3 equals x minus 4. So now I'm just looking at what number minus 4 gives you 3. That number is, of course, 7. So E is the answer. Number 2, what is the greatest common factor of 42, 126, and 210? Let's first talk about what a greatest common factor is. A greatest common factor is the largest number that divides evenly into all three of those numbers. The largest number that divides into all three of those. And there are some sort of math techniques of figuring that out, but in this case, we have these answer choices. All we have to do is see, which the biggest one of these that divides into each one of these. So, for example, looking at letter E, I know that 42 can be divided by 42, so that totally works. 42 divided by 42. So I know 42 is the greatest common factor of, the greatest factor of 42. So that's cool because it comes out to be a whole number. But does 126, does that divide by 42 very well? You might need a calculator to verify that, but sure enough, it does. It divides in evenly 3 times. Now the question is, does it go into 210? 210 divided by 42. I actually need a calculator for that. Or at least I'm going to use a calculator for that. And sure enough, that comes out to be the number 5. So 42 divides evenly into all of those, and that's definitely our answer. I mean, if you think about it, you knew it was probably going to be one of the bigger ones, not the smallest one. That would be sort of a silly question. So I was suspecting it was either going to be this one or this one that was the final answer there. Moving on, just some basic algebra simplifying work down here. Number 3, looks like we need to use the distributive property on that. 4x times x would be 4x squared, and 4x times 5 would be 20x, and that's all there is to that one. We're done there. Number 4, just a basic double distribution or foiling problem, whatever you want to call it. 3x times 2x is 6x squared. 3x times 4 is 12x. Careful with this middle part. I'm now doing negative 9 times 2, which will give me negative 18x. And then I'm also doing negative 9 times 4, and that gives me negative 36. Just be careful with the negative signs there, minus signs. If you do it in the same order as me, the middle 2 should combine together. They're like terms. In other words, 12x combines with minus 18x to make negative 6x. And finally, just bring down the minus 36, and we're done there. Number 5, the main caution here is that you need to understand that 2x plus 3, that quantity squared, is a harder math problem than you might want it to be. And also, you might be tempted to distribute the 5 first, but you can't. You need to let that sit for a while. So I'm going to rewrite this problem and go, to me, what I'm really looking at here is the number 5 multiplying not a single 2x plus 3 in parentheses, but double parentheses of 2x plus 3. So remember, a number squared means a number times itself, so 2x plus 3 times itself. At this point, you could distribute the 5 into this first set of parentheses, but I'm not going to. Again, I'm just going to leave that sit out for a while. I'm going to go do distributive property here. 2x times 2x is 4x squared. I'm going to do a 2x plus 3, which is a 6x, and another 3 times 2, which is another 6x, just to save myself some effort. Those are going to make 12x total. 6x and 6x makes 12x. And then finally, that's positive 3 times positive 3 is a positive 9. Now don't forget there is a 5 hanging out in front waiting to distribute, which means my final answer is 5 times 4x squared is 20x squared. 5 times 12x would be 60x. And finally, 5 times positive 9 back there would be a 45. And that is my final answer, 20x squared plus 60x plus 45. It's possible that you could have done that in somewhat different order and still got the same answer as me. Number 6, sort of a blown up version of number 5. So sort of rewriting this, first of all, remember that front part is more complicated than you want it to be, because it really means x plus 8 times x plus 8. I also have this minus 5x plus 4 happening back here. Alright, doing the x plus 8 times x plus 8, that's going to be x squared, and then x times 8 would be 8x, and then another 8x. I could have just combined those and got 16. 8 and 8 makes 64. I'm just going to keep on going back here. I'm having fun with the distributive property. Negative 5 times x would be negative 5x. And then a mistake you might make is forgetting to do negative 5 times positive 4 to make a negative 20 back there. Careful there. All right, let's see. Combining like terms, we have an x squared in front. We have an 8, and a 5 minus 5 that combine together. 8 plus 8 is 16, minus 5 is 11. And then 64 is going to do 64 minus 20 is 44. All right, a lot going on there. Hope I did that right. Check my numbers for me. Let's see. Number 7, I just wanted you to practice vocabulary again. We have a parabola, and this guy up here is the y-intercept because that's the y-axis that it's crossing. We normally say the y-intercept is 6, or y equals 6. We have these 2 points. Those are, there's a lot of names for those. We can call them the zeros, we can call them the roots, we can call them the x-intercepts, whatever you want to call them. We call them all 3 of those things depending on how we feel that day as math teachers. And finally, this bottom part is the vertex. Remember, the vertex is the lowest or highest point of a parabola. Moving on. Number 8 and 9, just wanted you to kind of practice some of these situations that come up from when you're doing the quadratic formula and you have to simplify, and just been noticing sort of some awkward things from students. So again, somebody's already done the hard work of the quadratic formula, plugging all the numbers in. What I'm noticing is that square root of 49 is actually the number 7. So to me, I'm supposed to go negative 5 plus or minus 7 all over 2. And then the thing is that that plus or minus is going to split this into 2 problems. I really need to do negative 5 plus 7, whatever that is, divided by 2. I also need to get negative 5 minus 7 divided by 2. And looking at those now, negative 5 plus 7 over here is positive 2 divided by 2, which is the answer of 1. And over here, negative 5 minus 7 is negative 12 divided by 2, which is negative 6. So essentially, I would just write my answer a little bit prettier here. X equals 1 and x equals negative 6. Number 9 is not going to be quite as kind to us. It's got a little different feel to it, because the square root of 8 is an irrational number. It doesn't really, just doesn't break down as smoothly. But there is something we can do. So off to the side, I've taught you guys to grab that number and think, is there a way of splitting that up into numbers that do square root, or at least one of them square roots? Well, yeah, 8 is 4 times 2. And the beauty of that is that square root of 4 is just the number 2. And so we get that. So now I can rewrite the original problem as 10 plus or minus 2 square root 2 all over 6. And that's a pretty good answer. We've changed it a little bit, simplified it. as they say. But there is a little bit more that can go on. It turns out you can shrink these numbers, is what I'm calling it. I've been calling it in class. I can divide all those numbers by 2, I've noticed. Now notice I did not divide this square root of 2 by 2. That's a separate deal. That's going to give me x equals 10 divided by 2 is 5, plus or minus square root of 2, all over 6 divided by 2 is 3, and that is a pretty slick answer right there. And we're done. Good job.